In this tutorial, we will learn meshing techniques for the objects imported from STL files and break down the process underwent through auto grid generation. Getting familiar with various tools for manual meshing would help to locally refine the mesh in case of complex geometries at later stage. For this tutorial, however, we will continue with the rather simple example from the previous video. Also, the corresponding exercise files are available to download from the link mentioned in the comments. As a recap, for the geometry modeled in SOLIDO, the minimum grid detects all the block points and generates the grid incorporating them. However, for an STL file, the minimum grid creates a bounding box around the imported STL geometry. We can better visualize this if we move the stud along the y-axis. Using transform coordinates, enter the y transformation distance as 30 centimeters. Now that the stud is displaced, from the Grids menu choose Minimum Grid. We see that the grid bounding the geometry of STL files is extended. Upon saving the file, you will be asked how you wish to save the STL file. If you choose to create a new STL file for the transformed stud, by clicking on Yes, you will see a new STL being created with the suffix of _t at the project folder where all the STL files are located. This is also reflected at the blocks window where we see the name of STL file linked to the current STL block. Now we will relink the block back to the original stud block. Double-click on the STL file location and choose the STL file of stud. Now, from the Grids menu again choose the minimum grid, to create a bounding box. A bounding box helps to check the overall dimensions along x, y, z axis. You can read the global dimensions of the geometry at the top of the grid window. As STL files have no scale, it is recommended to always check the scale at this stage. If required, you can change the scale from the Settings menu and then select Coordinates. Here you can adjust the units at the top field of the dialog. If you want to know the absolute coordinates of the geometry, go to the Fill mode to triangulate the object. Now if you hover the cursor on the surface of the object, you can see the coordinates of this point at the bottom status bar. Now if the cursor is moved horizontally, you see the y-axis coordinate not changing. From the Grid menu, choose Insert STL Coordinates. Then all the horizontal and vertical planes from the STL files are detected to generate grid meshes. Here, if the software detects a triangulation mesh for more than the threshold area in an orthogonal plane, it generates a grid mesh along that plane. Say we input the area of the triangle as 1 centimeter square. Upon clicking OK, the grid coordinates are generated where an STL triangled mesh is bigger than 1 centimeter square is detected. You could also leave the area of threshold triangle as 0 centimeters square. Now from the Grids menu choose Minimum Grid, to get back the bounding box around the geometry. We will learn to locally refine the grid. This works the same way as Trisco 2D, Trisco and Voltra. Select the grid we want to split. It could be one or multiple grids. Say X-axis grid, then from the Grid menu, choose Split. There are various options, we shall explore each of these now. First, the geometric method asks you how many segments you want the grid to split and what's the ratio. If we wanted to split into 3 segments with ratio 1. Upon clicking OK, you see that we get 3 equally split segments. We will undo this step with Ctrl+Z to see other split options. We again choose Split from the Grid menu, if we choose Maximum. The grid will split at every interval of the input distance, say 7 centimeters. You can notice the grid is split into fractions of 7 centimeters and the last grid with the remaining width. We undo the step and choose Split again, using the shortcut Ctrl+I. At Split window, Border 1, Border 2, and Border 1 and 2 define the cutting plane at a specified distance and split the grid. Borders 1 and 2 are the opposite ends of the grid. Suppose we wanted to create a grid in the center with a width of 2 centimeters. We choose Border 1 and 2 and input the distance from the border as 29, so that out of 60 centimeters, 29 centimeters is left from both ends and the remaining 2 centimeters is left in the center. After achieving this grid, you can undo this or go to the minimum grid to explore further options. Merge is used to merge the grids locally. Select multiple cells by clicking on the first and last cell holding the Shift key. Then from the Grids menu choose Merge. You now see these grids are merged, and using this technique you can make the grid more coarse in certain areas. Auto Merge will automatically detect all consecutive identical voxels and merge the grid meshes wherever it's possible. Lastly, from the Grid menu, choose Merge Small Grid Meshes. From the illustration, suppose the object has a slight extrusion. The grid would be generated using Insert STL coordinate along both lines. We can define a threshold distance using Auto Merge, say the limit is 1 mm. If the grid spacing is less than the threshold limit, grids will be merged. To summarize, the function Merge Small Meshes can be used to set the resolution of the geometry to be calculated. In the previous tutorials, instead of going through all these steps, we have used auto grid generation. The auto grid generation performs a mix of all these steps one after another to generate the calculation grid. Since the auto grid generation process also involves the step of minimum grid followed by several other steps, we can go to this command at any stage of the grid. It could maybe be the first step as we did in the previous tutorials, or at any intermediate grid stage as we do now. Say we go to auto grid generation, enter the required inputs, and then upon clicking OK, SOLIDO removes the previous grid and generates the new grid. We can click on Fit Blocks to visualize the triangulated mesh and Fill Grid to rasterize the mesh in the 3D voxel space and Fit Grid to fit the surface nodes to the triangulated geometry. Lastly, we will learn Autosplit function using an example natively modeled in SOLIDO using solids. We first choose the minimum grid, then from the Grids menu choose Autosplit. For smaller meshes up to 5 cm, the mesh would equally divide into segments of 1 cm each. If the grid is larger than 5 cm, then the split distance keeps increasing in the ratio of 1.5 beginning from the edge where there is a change of material. We can better visualize this after splitting. Here you notice that spacing increases in the ratio 1.5 as it goes farther from the material boundary. In this tutorial, we learnt about various tools in the Grid menu for automatic and manual meshing. Later, in the next tutorials, you will learn about advanced meshing techniques and some tips to perform calculations. Thank you for watching, see you in the next tutorial.